Tod runs Thing M, an IoT device studio based here in Pasadena. He is the creator of the popular, how do you pronounce this? Blinken?
Oh, Blink One.
Blink One. Okay, Blink One USB notification light and Blinkum? Blinkum. That's kind of fun to say, Blinkum. The smart LED prototyping device. He is the author of Hacking Roomba and a Make magazine contributor and obviously well known throughout the community here in Pasadena and a member of Crash Space? Crash Space. Cool. So I'm going to hand it over to Tod.
Yeah. All right. Hi. So that's me. This is the talk, and this is sort of a two-part talk. It's sort of like how the IoT infrastructure that we currently have sucks, and a slightly regressive way to solve the problem, and how I'm using that slightly regressive way to solve my particular problem for our little light here. And so this is all software. There will be a few part numbers mentioned, but it's almost all software. And I know, but larger point to make. And as it was kind of fortuitous in a Schadenfreude way, the recent problems we've been having with IoT devices, in quotes, attacking our lovely internet. And to me, there's sort of two main reasons why this happens. And one is that getting an IoT device on the net is hard. Like, these things don't have screens and keyboards, but yet we are requiring the users to input the information about, like, the Wi-Fi access points or whatever onto these devices. And so, like, yeah, you can get it on the net once, but what happens when someone changes their network? You know, grandpa's cable modem dies, he gets a new one, suddenly his thermostat doesn't work. And so what do you do? And there's really no mechanism for a lot of these devices to tell the world, tell the user, their users, that they need to be updated, or for them to even check that they should be updated, because a lot of them don't even have that capability built into them. And then the other thing is that, yeah, there's no way to find, to know if these devices are secure. There's long-lived devices that have no provision for updating their crypto libraries, which have time and again gotten exploited. So what do? Turn your device into a computer peripheral. Plug it into your computer, because OS updates are easy. Nowadays, keeping your phone, your computer, is so easy to keep updated. And this is kind of revolutionary. If you've lived in the world of, like, say, Linux 10 years ago, it was like hell to try to update your OS. You would kind of keep it in this pristine state, and you would, like, brag about your uptime days. But nowadays, you know, you just try to get things updated as often as possible. And even most of the desktop apps for modern Mac and modern Windows are also updated on a pretty regular basis. And the user can be notified of these. And the apps that can then auto-run to tell you that they need to be, something needs to occur to encourage the user to act upon changes. So the idea here is, hey, defer all of these security and configuration problems to the user's PC or maybe their mobile device, like their phone or something, because you can offload all the UI hassles, you can offload a lot of the security hassles to this device that has a much richer user interface, and you can avoid trying to jam that user interface into a device that's meant to be kind of hidden, like behind the closet or embedded in a wall or something. And this applies to USB, this applies to, say, BLE. You could even maybe do a Wi-Fi device if it's only on the local net, and maybe it acts, it doesn't know how to get to the larger internet, it just knows how to talk to one of the devices on your local LAN. And so why did I worry about this? Well, let me give a little bit of backstory. So here's me, that's my company, Thingum. We've been around for a good number of years. The thing we were kind of most famous for were these little prototyping boards called Blinkums, which are smart LEDs with a tiny microcontroller on the back. And they're pretty popular in the Arduino world for several years. They came out in like 2007. And for the longest time, they were the best way to get multiple RGB LEDs hooked up to your Arduino. The last couple of years, we'll be doing Blink One, which is kind of the same idea as a Blinkum, but with a USB port. And And I'll go into that a little bit more later. So what Thingham originally started as was a ubiquitous computing design studio where we would try to figure out how to insert intelligence into mundane things. And so two of these examples here, Wine'em and Glowpull. This is a wine rack that's smart, knows what's knows what wine you have, and will tell you what wine you should drink for dinner. And this is a sort of jewelry for your house. It's a standard drawer knobs, but they light up based on your presence or maybe other state, like what's inside. This is a little combo lock USB thumb drive that we worked on that we almost got ThinkGeek to buy into. Oh. Oh, sorry. And so mostly what Thingham has been doing for like its bread and butter has been corporate consulting for clients, and then these technology sketches where we try out an idea and see if there's a market for it, and then find there's not quite a market for it because we were doing this stuff so early that smart devices was kind of a hard sell to a lot of people. Nowadays it's much easier, but now we have the issues that we're currently having. But one of the things that became really popular was sort of this simplification of like what's the smallest possible intelligent device you could have, and it's this dumb little light. It's like just USB RGB LED is like the three-word thing that all it is. And but because it is so simple, we can hook it up to everything. Like we have APIs for kind of all the languages. It works on all the computers, and it's used by tons of companies because it's so flexible. They can hook it up to however the hell they want it to do. We're even in the Linux kernel, so you can load up a kernel module that's in like mainline Linux, and you can like do cat or echo color to the RGB device, and it'll light up the Blink one. Open source, about 30,000 of them we've made so far. And so this all started with some Kickstarters. They were pretty successful. And people often ask, geez, why don't you do a wireless one of these? And we've thought about it. For many years, we've thought about it. Had multiple different design iterations, multiple different technologies, sometimes Wi-Fi, sometimes Bluetooth, BLE. But they all had the same problem of configuration issues and also cost. That's kind of a big problem for a lot of these things. And so we go back to the very simple thing. This is basically just two parts, a PIC 16F that's got it's a built-in USB device and a WS2812. And that's pretty much it. The LEDs on top. Actually, there's LEDs on both sides. Microcontroller, and that's it. And but now this means that the computer has to hold all of the complexity. The computer is the IoT device in this case. So I kind of call this an IoT device, the Blink One, even though it's so simple and it hooks up to a computer, because it is performing a lot of the IoT tasks. Like it is this little light that lights up based on internet events, like new email, or Joe broke the build, or there's an incoming Skype call. And so you can imagine trying to collapse all that into a standalone firmware-based device. That'd be kind of expensive of the device. This thing could be really cheap, and you just have to have it plugged in. And so, okay, we want to have this cross-platform GUI that works on every API, works on every mainline OS, which is like Mac, modern Windows, Linux, Ubuntu, say. Talks to hardware. What language do you use? I've tried them all. So Objective-C and C# are actually pretty nice, but they're both in their own little silo. And so for a while there, I was supporting two independent code bases for the same app. And of course, Java, Java's good, but it just seems like the 15-year ago solution. Qt, also pretty cool, you'd think, cross-platform, pretty awesome. But while it does mostly work, it also will have these really annoying, weird crashes for some reason that are not clear. Even for very simple applications, they just won't run on some random version of Windows 10 or something. And so it's unclear what's going on. So, and what about Qt? The other problem with Qt is that you don't describe your UI in anything normal. You use this thing called QML, which is Qt's own little declarative JavaScript-like language for UIs. And so you're in this situation where you are using a a C++, like a not quite real C++ to host a not quite JavaScript GUI description language, and so suddenly the number of developers you can pull from is very small, because you've got you have to have both proficiency at C++, proficiency in this weird non-language language for UI description, and it's just So we went for about a year on Qt, and I got sick of it, and so I started looking into other solutions, and as an old crusty sysadmin web guy, I didn't think JavaScript was a solution, but it turns out, hey, you can do everything with JavaScript as an app now. So this is what the Blink One app looks like now. It's got a bunch of cool features. More are being added because it's pretty easy to add them now. Back when it was C++, man, it was like really hard. And the thing that I'm using is this thing called Electron. And Electron was created by the guys who did the Atom text editor. I don't know if you've ever heard of that. It's kind of the cool, hip text editor to use now. I'm an old Emacs guy, so I spent a lot of time trying to figure out how to make it act like Emacs. And Electron used to be called Atom Shell because it was literally this wrapper around a web app that they wrote that was the text editor that turned this web app into just a normal double-clickable application on your desktop. And now it's kind of grown enough to become its own thing called Electron. It's all open source. It's based off of the Chromium web browser, which is open source, and Node.js, which is open source server-side JavaScript. And the cool thing about, first, you might already be using something written in Electron. These are just some of the apps. If you go to Electron /apps or something, you can see a bunch of ones that people have added. And these are some big ones, like, this is a Visual Studio Code, I think is what it's called, the Slack app. If you develop with Particle, little Particle dev boards, the Particle IDE is actually an Electron app. Tons of things, it's pretty great. And so one of the things I use Onshape every once in a while to do some CAD stuff. It's this parametric modeler, kind of like SolidWorks, but it's all online. Someone decided having a fully awesome CAD system in a browser window kind of sucks. So they quickly made a little wrapper for it, and now it's an Electron app. Now to me it works better because it's a double clickable thing, and so it exists in a different headspace to me than a browser. So even though it's the exact same functionality, it's just when it's an app, I can use it. And so one of the ways that Electron works is it's based off of Node.js. If you guys have never heard of this before, this is server-side JavaScript, or JavaScript that doesn't run in a browser. And people use it now a lot like they use Python or Perl or Ruby, where they will write sort of system-level scripts to do little management functions on their computer. They type node and some file.js, and it will execute that file as if you were to type Perl, some file.pl. And one of the best things about Node is that there's this humongous library of packages, of libraries out there that's on npmjs.com, and you can just install it, try it out, try the little examples, and usually they work. Some examples that we use are IMAP, Skype, OAuth, MQTT. Actually, I don't use MQTT yet, but I'm hoping to. And this is amazing. Like, you can just install, and because most of these things don't really have a compile stage because it's all JavaScript. You just install and it's done. For some of the native packages, which we'll get into a little bit, these sometimes will have a compile stage, but a lot of the package maintainers will pre-compile the stuff for you, so that you just download a binary blob, and that's really handy if you don't have a compiler installed in your system, which a lot of Windows people don't, because getting Visual Studio up and running is actually kind of a pain. But look, here's some cool things you can do. Your JavaScript program can talk to serial ports, to Bluetooth Low Energy. You can scan and look for soft APs and connect to them, and this is all cross-platform, kind of just by default. It just kind of blows my mind. Like, trying to get something that does serial port stuff on Qt, you think would be easy, right? Because it's C++, and they've got a serial object. And it's just like, but no, not easy. I mean, you can do it, but not compared to this. Like, here's how you open up a serial port in Node Serial Port at 1900 baud, write stuff out to it after it's been opened, and read data back. And so if you're not used to JavaScript Syntax, this is kind of a little weird, but basically on the open event, this function is run. And so you just, when it's open, write this out. On data coming back, run this other function with the data that you get back and do something with it. And it's just like, this is kind of the standard sort of pattern that a lot of these libraries have. Super, super easy, super handy. Here's an example. This is the one that we use for Blink One. We actually have a wrapper package around this. But hey, I want to talk to this very specific USB device. I just create a new HID device, and I send a byte array to it, and suddenly my Blink One is purple. But you can also talk to things like the joysticks, barcode readers, that cool little PowerMate Griffin knob. All these things are USB HID devices, all of them accessible via the Node HID package. Another cool one is the Node dash button. So you might have gotten some of these dash buttons from Amazon because they were free or $5 a while back. And they're mostly kind of useless because who wants to buy cheer or whatever? But it turns out they emit little packets, and you can sniff those, which is what this does. This is actually running like libpcap in the background, and and sniffing the net. And when it finds the MAC address of the device, then it will do an event of your bidding rather than talk to Amazon. And there's a small config step here where you don't fully configure this so it doesn't order the cheer when you press the button, but it's pretty easy, and it's pretty scalable. I've seen people have like 8 of these hooked up, and they all do different things. Like this one, it turns on my lights. This one, whatever, reboots my router. And again, it's the same sort of functionality where it's all event based. So like when this event happens, run this function. And some of the ones I was looking at over on NPM just a few days ago is, hey, you want to control your little Parrot mini drone? There's a package for it. Want to control your BB-8 Sphero little robot? Package. Want to make your laptop act like a Bluetooth peripheral? So you want to maybe do some tests to see how your mobile app that should talk to your real device behaves. You can actually do that as well. Talk to DMX lights. You can use it to control and configure the ESP Wi-Fi modules, which I think this might be a really good solution. If you do have something that's based off an ESP, you can use this to help configure it. And if all this looks a little daunting because you're not that much of a programmer, hey, there's this thing called NodeRed, and this is a visual data flow. It's like visual programming sort of data flow thing that lets you take a bunch of these packages and they've been sort of repackaged in this visual metaphor, so you can just connect them together. And in this example here, it's getting tweets and it's finding English tweets, doing a sentiment analysis on it, getting the positive, like the not mean tweets, and then putting them up on a red scrolling sign, which is done via like a Node serial port or something like that. And then it's also doing some other stuff. But this is just one flow. You can have multiple flows. Once you define these flows, that gets saved out as a configuration file, which you can then embed in your main program. So if you don't want to figure out how to set up a whole data flow system for analyzing data or responding to internet to device, you can design it here, kind of shrink wrap it, and then embed it in your little application, and no one will be the wiser. No one, like the end user, wouldn't necessarily see all this. And then if you've ever played with Robotics, there's been this, you might have already seen this. This is pretty great. It's basically a library of robotics routines and a bunch of platform support using like Fermata for Arduino or running natively on like a Raspberry Pi or a chip or something. And, but it's all in Node, it's all in JavaScript. And so robots with JavaScript doesn't seem like something I'd want to do because it's not very real time, but you can do it. People have been doing all these crazy hexabot things. It's awesome. And they've got like enormous support for boards. This is only like half of the board list they support, and it's pretty amazing. Let's see, what do I got here? So you might say, oh, I'm a shill for Electron. And well, maybe. It's as a kind of crusty old web programmer, I never thought JavaScript was useful for much of anything. And I've been like super pleased at how amazing all this stuff has been. All the functionality is already out there. The community that works on these things are really positive, and like it's like I see the projects on GitHub evolve, and they evolve in a really positive way, which sometimes you hear about the tech industry, and it's all kind of mean. It's like, most of the stuff here, it's all pretty nice. Now, as for the downsides of our Electron app versus our Qt app, are these. Basically, it's you are starting up kind of a whole browser instance to run your app, and that is pretty overkill. And I'm hoping over time they can wheedle that down. But at the same time, you know, you're getting a lot of benefit. You're getting like a full crypto SSL library. You're getting like sockets, WebSockets. You're getting the full JavaScript engine. You're getting all the file I/O stuff, and you know, basically everything that a browser could do. It's got all that. So there's going to be a little bit of a footprint for that. It means the app starts up slower because you're kind of initializing the whole browser, and because it's HTML, the GUI that you create is going to update a little slower than native controls. But it turns out this update rate is about the same as for Java or for Qt, QML, because they're doing kind of the same thing. They're just like drawing rectangles on the screen rather than using the OS's libraries to do that. So my whole thing here, do you actually need to put your device on the internet? It's kind of the cool thing now because like, oh man, these ESP modules, they're like only about $1. I can put Wi-Fi on my thing, but oh look, my ESP module can't do SSL, and how do I update the firmware? It won't be a problem, you know. And so you know, it's just kind of a bad scene. I think if you're actually making a product, if you're hacking, that's great. But if you're trying to make a product, really think of it from the user's perspective, and they're not going to want to have to update the firmware because you got the SSID hard-coded in the .h file. You know, it's like you don't want to like hide that in some way. And so there's lots of good ways you can do the UI on a computer, on a mobile device, and periodically have the device talk to the computer via these various update methods that are out there. And Electron is one way to do it. Thanks.